Welcome guys to the fourth session for the beginner track of Zero Day Cybersecurity Club. In this class, we'll be talking about web fundamentals. All you need to know about the websites, how they work, and how do you do penetration testing on them. We'll go just to the pure basics so that we don't use any tools. All will be manual work here. Alright, so let's open a page. I just want to take this because it'll be easy for me now to explain. Alright. Now, when you open a website, there are three major parts of a website. One is the HTML, other would be the CSS, and the other part would be the JS, the JavaScript. So HTML, you guys must be familiar with it, right? The hypertext markup language, the skeleton of the entire web page. That is what we use to design and create the structure of how your website should look like. So that part is your HTML. The next part would be the CSS, right? The CSS determines your design, like the colors, the style, the margins, the borders, and all that stuff. Basically, how clean it looks and all the small details like color, animations and stuff. For the minor animations, at least. That is where your CSS is used. And the last part would be your JS, the JavaScript. JavaScript would be for your logic. For example, when we type a username password and sign in, what happens there? Because HTML can't do anything with that, right? It's not like a coding language. It's just a markup language where you can create stuff, but you can't embed logic to it. So for that logic, to maybe send this data to somewhere else, we can invoke JavaScript code. If you guys remember, the JavaScript code can be invoked by using script tag in HTML. It's like a redirection. So yeah, those are the three parts of your web pages. So first of all, how do you access the contents of the source code, as we call it, of a web page? We inspect the element. That's what I did. The shortcut is Control Shift I. Control Shift I for getting into the inspect element part of your web page. This is the same, I think, even for Google Chrome, right? It should be the same. Let's go to google.com. Control Shift I. Yeah, it's the same. In fact, even the view page is the same. Control Shift I. Yeah. Anyway, inspect element. When we inspect, you can see the left side here. This is your HTML of this entire page. You can the head part, right? In the head, you can see the name of the title that will be displayed, the links that may be required, and all that is in the headers. Then you have the body with multiple divs for modulating every single part of the page. And yeah, that is your HTML. The part here you see on the right, the middle part here, this is your CSS. The CSS here would be used for for, like I said, the padding, the colors, the font size, everything. You can modify all of them using the CSS. And you can see there's no JS directly here. To access the JS, you can see the JS links directly here. But a better way to do it would be to go into the storage, was it? Okay. Well, not. I think it's only there in Chrome. I see. Yeah, in the application. Sources. It's usually in the sources. There seems to be no sources in Firefox. No problem. At least in when you in Google Chrome, it's when you do the same thing. You can in the sources you can see the JS and everything. I'll open the same page here. If not, you can always just in the source code in the JS in the HTML itself, you can see the JS code here. Just click on it or control click and you will be there. I know the sources came out. Yeah. So in the JS now you can see all the sources here. Okay, it was in the debugger, my bad. Yeah, so these are the JS files. So there might be functions, function calls to to do specific jobs. Like for example, you can see here there is selection, class section models, and all that stuff is right here. So that's what's happening in the backend. But this is not totally there. Again, there'll be some other validation happening the server side too, which we'll talk about. Yeah, later. So these are the three parts: the HTML, the CSS, and the JS. And whenever you open a new website, if you are asked to do penetration testing, the first place to start would be here, because sometimes you might find some commented lines or some hidden inputs which might not be visible directly on the page but might be available here. Like for example, we just scroll through, maybe there might be some comments that might be there. Let's see it from here. Let's log out. I don't know, I like this, I guess just because the size is bigger. But yeah, you get the point, right? The comments in HTML will be with the will start something like this. It will be greater than, then minus minus the HTML code, HTML whatever, not just HTML, could be div or whatever, and again minus minus and close it. This is your, whatever's inside this is commented. So sometimes you might find some commented symbols there, and that could be useful information. I don't see, right? No doubts. All right. Yeah, that's in the HTML. Similar thing could be in CSS2. In CSS2 there could be sometime comments which could usually that's a long shot. CSS usually doesn't contain anything, but still it's good to always check. Excuse me. So you can see where is this exact part taken from. It's from academy.login.css. So you click on that. Yeah, you can see there are some comments here. So sometimes these comments could have some valuable information which we could use. So yeah, that's how you check it in the CSS. Same thing in JS too. JS also, there could be some comments that could be useful, or sometimes the JS function itself could have some logic that could be used to, which should be used by us. So that's why you need to check all these three: the CSS, the JS, and the HTML, obviously. And another way to, instead of inspecting element, you want just a raw HTML code for this, you use the page source, view page source. Then it will just have the pure HTML code there. So the CSS will be whatever is embedded CSS, that only will be shown up, like in the styles, or in the script for a JS, the script tag for JS. Other than that, everything else will be here. So there are some comments and everything. You can sometimes it could be useful for you. So that is the basic of what a web page consists of, components of a web page, if you can think it like that. Okay. So yeah, that is that. Now let's see the subdirectories. For subdirectory, let's maybe go to Amazon or something like that, because that has a lot of subdirectories, right? So now let's open in mine, because I don't want to log out there. Okay, this is no login, that's why. Okay, so now when you go to bestsellers or something, you'll see there are a lot of sub pages, right? /gp/bestsellers and all that. These are the subdirectories. So here sometimes what happens is, and by the way, when you see the question mark here, that means a parameter is being sent. Kind of like information is being sent to the user, to the server, using this question mark. This is usually like whatever's after the equal to might be different, and in here it's written ref, which let's assume it's for the referrer, because I think the button I clicked was, what was it I clicked? Today's deal, maybe. If I click now it went to this. Do you see the referrer changed? So like that, there are different other parameters that is used here, and hence the page keeps on changing. Like this, there could be many other such parameters, not just ref. There could be many more, which requires a lot of manual work. Okay, so like that, there are like that and subdirectories I said, right? /gp was a subdirectory. Like that, imagine for if there's a vulnerability, imagine there's a /files or something, all right, and then it is asking for a parameter called the name of the file, and let's again imagine it is index.html or something. This could be somewhat of a vulnerability you might find in some pages, because who knows if this is directly calling it from like the terminal, like there's an index.html available in the current directory. If you do like something like search and slash. If you guys remember, slash was the root folder, right? So you do something like slash root, or more usual approach is slash etc slash passwd passwd. This has all the users information of your the current session of your user right now, not just the current user, all the different users. And this is usually accessible to all the members of all the users in the given operating system. So like that, you can use this to get the contents and run it like that. This would be a huge vulnerability you might find. So stuff like this is what you need to probably look for when you try to do pen testing, or even for the assignment, which I'll tell you about later. Okay, so yeah, let's take one more example for the subdirectories. You guys, when you did the apt get installed, apt get update, right? You must have seen it hits these separate links. These are links, right? Where it gets the exact packages that already exist or which we need. So these, you can even access these repos. My repos might be different. Usually the repos which you might have would be like let me just check. What is the default one? Yeah, here it is. http kali.org/kali. Yeah, assuming you're using Kali. For Parrot, it's something similar. Yeah, so see here, now you can even access the files. This is how even your terminal sends a request and sees what it requires for in the update. So here you can see, you can even go through the different subfolders and it's directly reflected here. And yeah, even the .org, there you go. Here we can't access it because we don't have access to it. But imagine if we had access to all of that, and someone uses a similar subfolder a concept to create a web page. It could be quite vulnerable, right? Because again, if it is directly taking slash kali slash everything like that, yeah, let's just open a file. It downloads the file if it's directly possible. Imagine instead of slash kali, I put just slash dot dot slash, because dot dot will put you into the previous folder, right? If your current folder is home/kali, if you do cd dot dot slash or dot dot, it's the same. It'll go to the previous folder. So you can use that concept to go to the root directory and again maybe catch the etc pass or something. Yeah, this exact website doesn't support that. Well, it is safer than that, but yeah, that is another possible way to penetrate into a system. All right, next, requests and responses. This is going to be a bit complicated. All right, so what happens exactly when you type google.com? Like, how does it randomly just get us the text? There should be some sort of communication happening with between the client and the server, right? How does that communication look like? To do that, we can set up a small proxy now and check. I won't be teaching you how to use the tool. I'll be using Burpsuit for this. It'll be taught in the intermediate class, but for now, just imagine it something like this. Imagine this is a client. Let it be red, and we have the server. It'll be blue. So what happens is we send a request from the client to the server. Maybe I'll just write C. Client and server. All right. So we send a request from the client to the server. All right. And the client sees this request and sees like what it needs. Maybe it needs this particular URL. How much content does it need, and various other stuff which will be mentioned in the headers. We'll see now. And as a response, the server sends a response in the sort of from the server to the client directly, right? This is how your normal networking goes on. But what we are going to do now is we are going to set up a proxy in the middle. What it will do is, when you send the request will be first stopped by this proxy, and it will send its own maybe if, it can send the same thing directly to it, or you want to modify it, you modify it and you send it to the server. All right, and the server reads it, and based on the request it creates a response, and that response is again captured by the proxy. And the proxy, if you want to change the response to, you can change the response to and send it back to the server, or to the client, sorry. Oh my god. Okay, let's click it again, and yeah, like that, something like that. So this proxy usually is your proxy is managed by your if you're using Wi-Fi at home, it will be probably your Wi-Fi router. It handles all the requests and sends it to you. But after the Wi-Fi, now it's going to be a small proxy channel within our system, which here in this case will be burp suite. To learn more about the features of burp suite and stuff, that will be taught in the intermediate track. In fact, the video is already put up on the channel, I think, under the intermediate track. To start ready for the intermediate batch. You will be learning it in the next sem. A more detailed study on the burp suite in general. Alright, so proxy is on. I'll on the proxy even in the server. Alright. Now let's go to google.com. I'll just drop this last one. Oh, there are a lot of them, huh? Alright. Okay, let's go to google.com and enter. So you'll see there was a request sent to google.com. The request type, the first the word here would be something called method. There are different methods in HTTP which we use, HTTPS, HTTP methods, just HTTP methods. Each one has its own purpose. You can, I think it'll be there more in Mozilla website. First let me just go to the syntax maybe. Slash would be your, like, imagine it as your subdirectory, like google.com slash it's going. That's basically google.com, right? So that HTTP 1.1 is the version of the messaging protocol that's being sent. And after that, in fact, even the host, these all are what we call as headers. These headers send information to the server about us, right? So it will tell what type of, from where are we communicating this. This is a Mozilla 5.0, right? It will be the same in Mozilla Firefox. Directly you can see it. If you do it from a Chrome website, I think I have burp here also. I'm saving this. Where's burp? Oh yeah, burp is here. Yeah, burp suite is available even on Windows. Just, by the way, any doubts until now about HTML, CSS, JS, or subdirectories in general? I'm going to assume not. Alright, so google.com. I'll just turn on the proxy again and enter. Same. So slash request, but this time see the user agent. Again, it's Mozilla 5.0, but this time it's Chrome, not Firefox. So that is a user agent. Even you can modify the user agent. That will be one of your tasks too later. So you see, you can change it. I can remove it and put whatever I want. But yeah, I don't want to do anything like that of sort. Yeah. And accept is what accept header does it. It tells the server what kind of content that will be sent to the client it can accept. So it can accept HTML responses, or XML responses, or any image responses, or video responses, stuff like that. Yeah, and these are all like similarly similar headers which will be used. Another important one would be the cookies. We will talk about more about that in detail a bit later. Yeah, so this was the request, right? So you send this to the server, but what is the response? What do you get back after you send this? So I just on that response and forward, and I wait for a response. Yeah, response is same. Response, this is the status code, response status code. This you might have seen these numbers, right? You must have seen 500 error, like 404 error, server not found, 404 is not found, 500 is server error. These are all HTML status codes. All of them, you can search more about. The 100 series is for information, 200 is for, I think, confirmation, 300 is for redirection, 400 is for 400 is for client errors, and 500 is for server errors, I think. Let's just search it. Mozilla.com sends it. Yeah, perfect. Informational is 100 to 199. Success is 200 to 299. Redirects is 300 to 399. Server client errors is 400 to 499. That means we have a problem from our side. 500 to 599 is server error, like something is wrong with the response itself. So now it might make a little more sense. Did I off it? I offed it here. Yeah. Enter. Again, same request. I'll intercept the response. There's some more uh, requests were sent. So here's the response. Yeah. Now 200 OK. 200 OK is a good response. The request has succeeded, and it'll depend on how it is sent. This is the different methods which I said. You saw, right? When we send the request, it was a get request. Similarly, there's a post request. We'll be using get and post mostly. The put, delete, head, and trace are used more in for the database side. So that's not the more important part. We'll be learning more about the get and the post. Get request, you saw it was to just send request directly with only one URL. Maybe it has a parameters, it'll have it. That's it. Yeah. And you saw the response 200 OK. And similarly, like how we saw in the request, there are many headers in the response too. And some important headers you can see is set cookies. Again, cookies are coming here and there. And yeah, you can see the type of content. You remember that time we saw accept, right? In accept, we said we specified what type of content we want. HTML was one of them, text/HTML. So that is the type of content that the server is sending us. And content length is there. After the content length, well, the content. This is the entire HTML code that is right here. In fact, that will be put there now. You can inspect it. It will be the same what was there here. Yeah. Okay, now similar to get request only required one URL, right? We just sent the URL request, it required nothing else. Post request could be used to send URLs along with some data. This would be useful when you do login information. For example, I don't want my login username and password to be directly here in the URL, right? I don't want something like this, then user equal to Vihar, password equal to something. That's not safe and not ideal, because if someone is snooping or like someone is acting as another proxy other than us, our entire information is leaked now. So to stop that, we send it in the post request. Post request allow us to send some data too along with the get request, along with the URL. And yeah, you can send the information and the server will make sense of the information and appropriate output will send it to you. So these are the two type of requests we'll be using. There are a lot more. Do not think these are the only ones. I'll just show you some other ones too. Methods. You just search it and you will see the different methods available yourself, because there are a lot of them, and each one would be important when you later do web development. Yeah, third sem, I guess. So that time the these methods, the status codes would make a lot more sense. Come on. Okay. The get request was, we saw that. Then there's a post request. We can also submit an entity. Entity is your data which you are sending to the resource. Then there are separate put request, delete request. Yeah, all of them are available, which we'll be using for different reasons. All right. So with that, now you know what is the request and response. The most important thing you must remember from the request and response is the headers. Because you will have to modify, you can modify them, right? That means you can manipulate what is being sent to the server. Let's open network and maybe search HTTP method only. Okay, you can see the number of requests that were sent and what are the responses we got and everything. You click on, see, these are all the requests that were sent. Request to API.js. This is, I know there's no proxy on, but Google Chrome will receive the request, the responses, right? That's what we are noticing here. We can't change anything. This is just whatever information which we have received. So when I click them, you can see more information about it. Let's make this bigger. So see the request URL, huge URL, the method, the response that we got, 200 OK response, and the remote address. Remote address is the current user. Yeah, so the response headers which we got and the request headers that we got. All right, so these request headers and response headers would be very useful, and even for the assignment again, you will need them. Some important one would be the referrer. Referrer is your like, for example, now from google.com I go to facebook.com. The redirection happened from Google to Facebook, right? So Google would be the referrer for Facebook. Basically, the previous URL that sent us to the new URL. That is your referrer. Your referrer would be origin because, well, that is the first command that we put. The first URL that we sent in. So that's important. Then, yeah, the user agent I already said that would decide what type of user you are. Based on that, well, you'll think only users are the browsers, right? But that's not usually the case. We have bots, right? You must have seen those Twitter bots. There are Google bots. I mean, Google must index all these pages, right? How does Google get all these pages on its server? That means it must have crawled through the entire website and seen the websites, and then understood what is the header available, what is the title available, and it indexes it in its own database. To do that, Google must have a lot of bots. Well, it can't do manually this many searches, right? So that is one type of use of the user agent. Yeah, and that's about request and response. Okay. Now let's go to cookies. Okay, cookies. You must know what are cookies, right? Anyone who has a vague idea of cookies wanna pitch in a definition? Anyone? What are cookies? You must see them everywhere in your web pages. You must have seen the prompt at least, right? Maybe when you open a news site. Open any news website, almost all of them have it. It will come up now. It can come up. Which it comes up. Open incognito. Maybe there's already a session that is opened before, so maybe it couldn't find. Usually you will see it, right? Okay, I'm not getting the prompt. Usually you get the prompt, right? This website uses cookies to track your data. Do you accept? Yes or no? You put a yes, and usually you won't see any difference, but in the backend there's lots of changes happening. So, well, first of all, you saw how it is being sent, right? You saw the cookie and the set cookie headers that were sent. What are they used for? So, as you saw, the cookie is now like a permanent resident along with your HTML code. So you saw HTML, CSS, right? Along with that, if you went to where was it? Application, yeah, application. In storage, cookies will be there, and these cookies hold information that will have to be passed through multiple pages. For example, yeah, let's take the login itself. So imagine you logged into PS University and you got in, right? After that, every other page you get in still has your information, right? It does not ask you for the password again, right? Now I went to my courses. Did it ask me for the information again, the username, password? It didn't. But the page did change. But still, the login information was intact. That is done because of the cookies. Because the cookies still holds the information. They hold the information from the previous URL. Because you saw, right? It's just a header. So the header is just continuously being rotated. The request has the header intact, and the response doesn't change the header. It just keeps it like that, and maybe if he wants to add something new, it adds it there. Other than that, it remains the same. So in that way, the cookies help you to track a user. This is how even ad agencies work, right? Your ad, like Google ads, how do they work? How do they know what did you search for? For example, now I searched for maybe chocolates or something. You might see a lot of chocolate ads. You might not see here because I blocked every ad. Yeah, see, you will see ads like this, right? One here, one there, everywhere. Yeah, maybe I search for apartments. I don't know. I should know. I don't know. It's depending on. You might not see the same ads, right? I don't think so. You'll see the same ads. It might be something different for you. Why is that? Because this particular site, now see the number of cookies because I removed the ad blocker. So yeah, the cookie, like see the GID usually are the Google Analytics cookies. These cookies will be continuously monitoring you through the entire while you surf this entire website, India Today maybe. So when you move to a new site, that cookies will still be there. It didn't change. Some new cookies might have come, or they might have appended new information to the cookie, but the core information remains the same. So now imagine you searched for news. I was looking again, maybe chocolates. I was looking for new types of chocolates or some chocolate recipe. That information is now holded by this cookie, and later it could use it to give me more results of chocolates, or more searches on chocolates or something like that. So in that way, cookies are being are used to track you. And yeah, it's not just for tracking, it's even a positive aspect. As I told you guys, was the login. You can use it for logging and uh, logging in and making sure you're continuously logged in. That's why maybe if you're already, for example, yeah, when I put amazon.com, again, it didn't ask me for the ID, right? It directly signed me in. I'm in incognito, so no. If it's not incognito, you saw it already signed me in. That's because the cookie was already there. It already was set. Sometimes the cookies usually are deleted when you close the site. Sometimes the whatever information was there is set into the local storage and your session storage. See, there are some already information set already here. Some of these are permanent. They will be there even if you close the browser. That is what is consisting of your cache. That is why people say to clear your cache, regularly. Because imagine if you surf through a lot of pages, the cache slowly increases and it might be too much at some point and might block some. Could be a memory blockage or something like that. Anyway, so that was cookies and headers. Alright, now let's go to another important topic, that is robots.txt. Alright, now I told you just before that there are separate user agents, right? User agent was the header that we use for telling what type of user was it. Like, am I browsing from the URL from a browser, or am I a bot, or I'm using a Python code to send the request or something. You can do that, by the way, or something like that. That is what where is it? Is it here? It should be here, right? The request headers, user agent. There you go. Yeah, user agent is Chrome. But imagine a bot actually does want to. A bot is being used to surf the web, but you don't want the bot to access some certain pages. Maybe those are confidential or they have login information. You don't want someone to continuously keep sending bots to attack your login page or something like that. So that's why we create a page called robots.txt. It's a text file. So this robot.txt is used to make sure some pages are disallowed, or not allowed to be accessed by some particular user agents. In this case, every user agent. Star means all the user agents. All the user agents are not allowed to go through these exact pages. That could be because of some particular restrictions. Like I said, it could be sensitive information, or or something related to the current situation the page is in. Maybe you are already in the checkout. It doesn't want you to send it back to you send you back to the original page, the home page. In that case, you'll be fine that it'll make sure that you don't by mistake also don't go back to the previous page or something like that. So yeah, user agent star is not allowed here. For user agent ETO spider, it's not allowed. It's not allowed any page. Twitter bot is not allowed in these particular pages. Amazon bot is allowed everywhere. It's not a disallow is nothing. So yeah, so like that you can make sure that these pages so usually that means these pages are secret, right? They have something important in these pages. And imagine you do have access to these pages. You can open them and see, right? You can open it, and maybe if something sensitive is there, you can see it. When you're doing penetration testing, that's helpful. Here there's nothing, but imagine in a normal other pages also the robots.txt exist, and you could access some new pages that were not seen from various other tools. You use some automated tool to search through all the subdirectories and couldn't find it. In robots.txt, it was just one click and you could find everything. That's one way of using robots.txt to check through hidden pages. So now we went through the different components of web page, the subdirectories of web page, the request and response, robots.txt. Alright, that is the basics of what is web page, and what are the different functions around it, what are the different headers and responses. Now we saw what do we use and how does it work in the behind. Okay, so what are some famous, let's just go through some famous exploits that are available, vulnerabilities that are available. Vulnerability as in a weakness available. That means maybe faulty programming or, wrong use of the software or something like that. You guys, have you heard about SQL injection? Anybody? Hello? Have you guys heard about SQL injection? It's one of the most famous vulnerability available. That's the one everyone talks about every time. Any idea? I am guessing no. Alright, so now we'll just see how let's not say how, because I will not be showing you the code to exploit this or something, but maybe why it works. Why does SQL injection happen? Why is that a vulnerability or something like that? Okay, now this is a very interactive a page. Hacksplaining.com is a beautiful website to learn new vulnerabilities or how they work. At least it doesn't have the code or some exploit directly. It just says how do you use the vulnerability and what does it do. Hacksplaining.com. So let's see. So imagine a bank page exists. All right. So in the bank page, I am trying to log in. So I log in as user@email.com. Oh my god, email.com, and password is password. All right. Okay. So okay, you didn't log in because, well, that username doesn't exist. But you guys know MySQL, right? That's what SQL injection is all about. I mean, backend, something must be there to control what is happening here. This data must be sent to the server, maybe using a post request. And once it is sent, what's happening there? How it is being sent could have some problems which we could exploit. Alright, so total to use password -paswrd and user@email.com. Okay, and you log in. The server crashed. Imagine this is a real web page again, and maybe the server crashed or something. Some issue happened just because you added a dash after the password. Why? Why did that happen? So imagine the MySQL code that is running behind was this. You must be familiar with this syntax, right? Select star from user, select star from table, where column equal to this, or entry equal to this, and one more entry is that. Limit 1 for 1. So this is one possible code that is running behind. Let's imagine that. So when we put dash, what happened was the code got closed. It didn't sanitize, or it didn't ask you for anything else, right? It just took the dash directly without any conflict, without any problem. Because of that, what happens is the password is closed now directly. So whatever comes after this, one more code, that is a syntax error, right? There are two codes in succession. The password code is complete, but there's one more extra code. That is why the error was occurred. So we could use this to we can use this vulnerability, but because now we know it is being closed, and this is the exact code that was used. What if we do something like what's written here? Dash or 1 equal to 1 minus. Dash or 1 equal to 1 minus minus. What happens now? What happens now is, first thing is we close the pass equal to the string. The string is closed. Then now we write or 1 equal to 1. When you do or 1 equal to 1, first of all, what does 1 equal to 1 always give? It's a true statement, right? And according to or, if even one of the statement is true, it will accept. It's a true condition. And we put the minus minus so that whatever is after this 1 equal to 1 is commented. Like how in Python you do hash, right? To comment single lines and double quotes or triple quotes to comment whatever's after. Similarly, we put minus minus to comment out every other line that is following this. So now what the query will be is select star from users, where email equal to user@email.com and true, because this or statement will give you true. So I'll select star from users where email equal to user@email.com and true. So it will basically log you in as user@email.com. There you go, and you now have access into the account. So this is how the base SQL injection works. But obviously there is a lot of trial and error, right? We don't have access to this code at all. We don't have access to this. Only we have is the front end web page, and maybe sometimes the error logs come up. Then maybe you could that could be an indication that you're going in the right direction. Other than that, you have nothing. So Like this, you could maybe exploit other what you call languages too, not just SQL. This is called like what you call a faulty coding in a way. Can anyone suggest a way to like bypass this? Like, how do you stop SQL injection? Right now, you saw that a person could put dash and close the code for close the string, and whatever is following is executed. So how do we stop them from doing this? Any possible solution? Any suggestions from you guys? Guys, anything? Come on, be interactive, no? A bit. Any idea? What could we do to stop people from trying to exploit like this? I see no response. So, okay. Well, the easiest thing is, well, stop them from using codes. So when we typed quote only, the problem came, right? When we put password dash is when the issue occurred. Then stop them from putting dash in the password field. That's it, right? As simple as that. So when you should first of all not have passwords which have dash in them, and the user enters it, we should make sure that it checks no dash symbol is being used, not just single quote, maybe double quote too, the double quote, because sometimes it was instead of it was not select star from user where email equal to, so not single quote user at email, user at mail. It was double quote. Instead of a single quote, imagine it was double quote. Then, well, the exploit would be simple. No, instead of single quote, you should put a double quote there. That's the only difference. So now we will have the user input would be, when you ask username, you should put quote here. Then the quote will be put here. And now if you put a minus to comment everything else. Okay, and whatever's in the middle would be the command executed. So well, here it is or1 equal to 1, right? So it will become here or1 equal to 1. Only difference was single quote is not double quote here. That's the only difference. So like that, this is not just the only what you call SQL injection code. There are many more. There are separate exploits, like not just using or1 equal to 1. There's union injection. There is using just the search query in itself, the URL query itself. There are a lot more ways to do this. You can, for more details, again, you'll learn more about this in detail in the intermediate sessions. So that is SQL injection. All right. Another one famous a vulnerability is command execution. Well, imagine like how SQL command was there. There's now a PHP command which directly runs the command in the shell as in the terminal. Let's open a terminal. I'll close that. All right. So now look here at least. The code is doing system ns lookup domain. First of all, what does ns lookup do? Let's just see. Ns lookup and domain name, right? That's what the input is being taken from the user. So imagine the domain name is google.com. That's what they sent. All right. It's giving you this output. So what maybe was happening in the backend was it did something like this. ns lookup google.com. Oh my god. Yeah, same output, right? So something like this was being done in the backend. This is super dangerous because if you guys remember from the Linux fundamentals, there are different ways to make sure this is not just a command. We can pipe the commands, right? Remember the pipe symbol which we used to like send this as input to the next command. Similarly, there is and which will execute the command. Whether this command fails or passes, it doesn't care. It just executes the next command, or a semicolon to execute the next command after this command. Using these various ways, we can basically skip the first command and execute our own commands after that, right? And use like that, you can now basically write whatever you want. So there, if you put, you remember cat, right? Cat was to output whatever is there in a particular file. Then etc password, like I said last time, is a sensitive file inside the. It's usually there in every Unix system and Linux system at least, and it contains the users and different softwares in the system. So yeah, it gave the output. In fact, you do it here also, it'll be the same. Do cat etc/password. There we go. First it does the first command, obviously, but after that it even executes the second command, and that also comes as output. So like this could be used to as penetration vector, and we could do some really what do you call it? This could be a wrong. This is wrong access. So hackers could use this to get into the system, open sensitive files, or even execute their own commands. Right? They could open a netcat shell, and if you remember netcat like from last time, they could open a netcat shell here and get a direct terminal itself on the system. So that is super dangerous. And this command execution will be very important again for the assignment. And that was command execution. Alright, that's all for the session.